Hello, everybody. A very, very warm welcome to today's rapid fire session. This is me, Nitika, your host, your dose, your catalyst for the day, and holding the quiz master mantle for today. And without taking any further breath, let me quickly introduce you guys to the three amazing participants for today. Let's have them out here and let's get to know them. And before anything they start telling about themselves, let me quickly know out there in the chat also if I'm audible and visible. So a quick thumbs up from you guys would really help me in understanding if I'm audible and visible so that we can hear out our participants for today. Cool, I can see Parv joining in, Ankit, Pritu, Jay, Shri, very good. So I'm audible, I'm visible, I've been given a good to go from everybody. So welcome Raghav, Shreya and Sanatan. We'll quickly have your introduction starting with Raghav. I would like to know, where are you from? What are your hobbies? Which is your favorite subject? And how are you feeling today?
A very good evening, ma'am and everyone. I am from Punjab. And my hobbies include reading fictional, non-fictional, and any kind of books and playing chess. I'm feeling very good today. Did I miss something?
And which class you are in?
I'm in 11th class.
All right. Welcome, Raghav. I'm very sure that today your fictional and non-fictional knowledge would really help you for States of Matter. Welcome, Shreya.
And my favorite subject is maths.
Math. Oh, we have lots of math lovers, I must say. Cool. Shreya, yeah, how about you?
Yes, ma'am. Very good evening to everyone and also to you, ma'am. I am Shreya Bhattacharya. I live in Kolkata, that is in West Bengal. And my hobby is in doing drawing, painting, singing, dancing, and also reading storybooks. And I like to read adventurous books a lot.
Wow, cool. So we are book lovers, to two of them today. Great. Shreya, which class you're in?
I am in class 12 now, and my favorite subject is biology and chemistry.
Oh, lovely. Good to hear somebody likes chemistry. Okay, Sanatan, how about you?
Hello everyone and namaste. I am from Bihar, Patna. I am currently in 11th standard. My favorite subject is mathematics and chemistry. My hobby is to do hard solving problems and studying more and more and playing.
Wow, studying more and more is your hobby. What better, guys? What better, Sanatan? So I really wish you all the very best. Make sure today it's rapid fire, and everybody knows what a rapid fire is. You're rapidly supposed to fire the right answer at me. And the speed matters. So hashtag speed matters. We have audience also out here who will be rapidly firing answers, and I'll try to misguide you guys and guide you at times. So we'll see whether you listen to the audience at times or you won't. I'll quickly give you the instructions very quickly, because I'm probably knowing everybody out here knows how we go about in the rapid fire Mondays. We have speed, hashtag speed that matters. So make sure you're ensuring your speed, but with accuracy, of course, because we have negative marking, a -1 for the wrong answer. So make sure, maintain your speed. Last time in the rapid fire Monday, which was on P block, we had the speed that only mattered, right? Questions were pretty easy, and so are they today also, let me tell you. You would require a pen and a paper at places, but at places you would not require a pen and a paper. So I request all the audience out there and all three of you to be ready with a piece of paper, a sheet and a pen, so that if we have a numerical question, you guys are rock and rolling, okay? And States of Matter is the topic for today. When I talk about states of matter, no, we are not going to talk about Bose-Einstein condensate or plasma or solid state. We'll just focus on gaseous state and liquid state. And to be honest, it's mainly gaseous state. At places, you would require some liquid state, but mainly it's gaseous state that we will be focusing on. That means the syllabus is from class 11. questions are handpicked by us. And you know how creative our teams are. So we have picked up, very interesting questions, simple questions at places, which can be given, which can be bombarded at us rapidly. So rapid fire is in true sense. Without now any further ado, let's get started with the first question of the day. I hope you guys are ready. Thumbs up. Cool. First question, guys. Let's see. For an ideal gas, the plot that is non-linear is PV versus T, PV versus P at constant temperature, P versus V at constant temperature, or all of these. Thank you, Googler. Okay, we have some of the people who are already guessing who will be the winner. Sanatan, you're getting lots of votes out here. That's great. Shreya was very quick. Use your own mind and make sure you manage speed with accuracy. Cool, cool, cool. So the first one was, what do you think? PV. PV. So I'll quickly give you guys some tricks also, because this is not just about giving the right answer. This is also about learning. And when we talk about ideal gas, we're talking about here P and V mostly in all the options, like you can see. So which law are we talking about when we relate pressure and volume?
The Boyle's law.
Boyle's law. Bilkul sahi. Raghav is absolutely right. So Boyle's law, बात तो यही है ना कि pressure और volume, how are they related? If we increase the pressure, the volume would decrease, isn't it? Imagine a container, if we increase the pressure, the volume would decrease. So P is equal to K by V. How come it is a linear equation? It is not, right? So C should be the right answer, isn't it? What do you think?
Yes,
So A, B, and D, all three are wrong.
All are correct.
All are wrong. C is the correct answer, guys. PV versus T or PV versus P would be a linear curve because PV is already a constant, right? And PV versus T, when we are talking about, so obviously we are talking about PV is equal to nRT. R is already a constant. We talk about fixed number of moles. So PV is equal to constant. So that would also be a linear curve, not a non-linear curve. So right answer is option C. Let's have the answer. You can quickly see how the curve looks like. This is how the curve looks like. P is inversely proportional to V, like you know. As we increase the pressure, the volume decreases. And you can always remember it like this. BT, Boyle's temperature constant. Boyle's temperature constant, BT. So what are the two things which are there? You have pressure and you have volume. If you increase the pressure, imagine a piston, the volume would decrease. Similarly, you can remember GV, BT, GV. What is GV? Gale-Lussac law, volume constant. What are we left with? Temperature and pressure. If we increase the temperature, the volume would increase. Imagine if there is a heat below, if you're increasing the temperature, the volume would increase, right? Similarly, you can remember CP, Connaught Place. None of you is from Delhi, but everybody knows CP probably. CP, Charles' law, pressure constant. So we have T and V. Imagine if we are increasing the temperature, what is going to happen? The volume is certainly going to increase, right? So GV, BT, and CP, and ATP, adenosine triphosphate, no, ATP, Avogadro law, temperature and pressure constant. So as you increase the number of moles, the volume would increase. So guys, make sure you also remember it, all the 4 ways of remembering. So here the answer was C. Okay. So -1. That's a great start for all 3 of you. Wonderful. Wonderful. Let's see. The fun now begins. Next question. Question number 2. The compressibility factor of a real gas below T is equal to A by RB will be A, 1, B, greater than 1, C, less than 1, D, cannot predict. Sachin, Punia, you're asking who are these students? So they are students who have been picked from the registration, they register on Friday when we roll out the registration forms, and we pick the lucky 3. And whosoever will be the winner out here will be getting some goodies and some packages. Wow, lovely. A session on GOC. Okay, noted, go Karna. Okay, there is a friend of yours, Arshu, saying B. There is Arjav Jain saying C. There is Mahindran who is saying D. So no help coming out from this audience, trust me. Yes, Sachin, absolutely. So those of you who are asking how can we participate in this, Medansh, we roll out on Fridays the topic as well as the registration form. You have to fill the registration form and you can be a part of this. And you're certainly a part of it right now as an audience for sure, right? Cool, we have answers. Raghav giving C, Shreya giving C, Sanatan giving B. That's interesting. So what is T is equal to A by RB? Anybody can tell it to me? T is equal to A by RB. What kind of a temperature is it? A critical temperature, Boyle's temperature. That's right, Shreya. Wonderful. So we know that Boyle's temperature is the temperature at which if there is a gas which is maintaining Boyle's temperature, then it's maintaining the ideal gas behavior for an appreciable pressure, right? Well, when we have, we are talking about Z, the compressibility factor. So if you're talking about the compressibility factor of a real glass below this TV, of course, Z will be less than 1. So Raghav and Shreya here are opening up. Great, superb. But Sanatan, that would be a wrong answer to say. It is greater than 1. So A is wrong, B is wrong, D is wrong. Certainly, please see the right answer here is option C, right? Cool. What are the scores now that we have? Shreya going on 3 and Raghav now opening their bank accounts. And here we have 2. Sanatan, buck up. We have the full audience vouching on you. So next one, you have to be quick and correct. No pressures though, because here when we're talking about Boyle's law, let's see the quick answer and let me show you the graph as well. This is what we're talking about, Z less than 1. You can see below the ideal gas, this is what the scenario will be, the compressibility factor will be when we are talking about the temperature less than the Boyle's temperature. So catch here was to find out what is A by RB, Arab Boyle's, right? Cool. Next one, guys. Question number 3. Let's see. For a gas at constant temperature, what is the ratio of collision frequencies at 200 Kelvin and 800 Kelvin? The ratio is what you have to tell me. Option A, 2:1. Option B, 1:2. Option C, 1:4. Option D, 4:1. This is easy. Very easy calculations too. All right. Arjav, get a +4 for this also. Let's see whether you can give a right answer here or not. Googler is saying option A for this particular question number 3. Let's see who else is giving the right answer here. We do not know is right or not. Tech Live Gamer is saying C. Yajat is saying A. Aditya is saying C. Adinath is saying C. And don't expect me to be mute because I'll be the surrounding that creates a lot of disturbance for you. So you would have to manage with the disturbance that's coming up. My job here is to deviate you guys and yet get the right answer from you guys. Cool. So what's the formula you're applying?
The collisions will be that is proportional to temperature.
Directly proportional? to the temperature or root of the temperature? So let me tell you guys, it is the root of the temperature and not directly proportional to the temperature. So that's what you have to be careful about. Z is directly proportional to root T. So if I'm talking about Z1 by Z2, it will be equal to root T1 by T2. So 200 by 800, that means 1 by 4. That means if we're taking a root of it, we get 1 by 2. So B out here should be the right answer, guys. So -1 coming up. Wow, I love it. I love negative markings. Because let me tell you why I love negative marking. Not because, negative marking is something that you would never like. I'm pretty sure. But now whatever answers that you're learning, you would never forget it. Don't you agree? So learning is very important. Mahatma Gandhi once said that you may not know the results of your actions, but if there are no actions, there'll be no results. So it's important to write here and learn. Learning should be the fundamental goal. So now root T is something that I am sure Raghav, Shreya, and Sanatan will never forget. And so is our audience out there, isn't it? So Arjav, B, here we have very less B, let me tell you, an audience also coming up. So B is the right answer. Let me quickly show you the answer once again. So this is what we are applying, right? Z is directly proportional to root T. The collision frequency is directly proportional to root T. Get that thing straight in your head. Cool? So amazing. Wow, lovely. I'm loving the scoreboard. It's showing some kind of a series, 1, 2, -3. So we have long way to go, and you will see the things changing just like that, because that's what rapid fire is all about. So never be discouraged and make sure that you are in the best of your spirits. Question number 4 coming right on your screen. Predict the correct order of values of critical temperature for the gases NH3, carbon dioxide, oxygen, nitrogen, and helium. And you have options A, B, C, D right in front of you, where ammonia is leading in all the series. So that's a great help. You know, critical temperature would depend on what then? Cool. So let's see. Googler, tell me what is the answer coming up. Shikha is saying C, and we have others. Anybody B? Anybody B? A, D. Okay. Okay. Let's see. Audience is like doing an awesome job out here for this particular question. That's amazing. Buck up, guys. It's a very easy question. Shreya has bombarded the answer right here, and I think she's the quickest one. I am telling you, the speed really matters, and I'm pretty sure that that is what will be the deciding factor today. So make sure, guys, you buck up. C is indeed the right answer. I do not think so that this question requires any of my explanation. You can easily get to know. The examiner has been kind here by writing ammonia in the very first of these options. This gives us a fair sense that ammonia we are talking about, intermolecular forces must be high. Intermolecular forces of attraction depends on hydrogen bonding. If anybody of them would be showing hydrogen bonding, which is ammonia in this case, which examiner only helped us out. So we all need to find out for carbon dioxide, oxygen, nitrogen, and helium, which we can do so by the molecular masses. So let's quickly see the answer. Greater is the polarity of the gas, greater will be the critical temperature. So you know that we're talking about critical temperature, ease of liquefaction. Ammonia being most polar of all have the highest critical temperature. Other factors on which critical temperature depend on are molar masses, right? And the strength of the intermolecular forces. So of course, ammonia was a common in all the 4 options. Then we have carbon dioxide, then oxygen, then nitrogen, and then helium. You know why, right? Atomic number, atomic masses, molecular mass is what we're taking care of, right? So what's the scoreboard like? Can we quickly have the scoreboard? Raghav 4, Shreya 6. Yeah, the women out here is leading. Great, superb. Sanatan, great. -1. Let's get you in the whole number very quickly now. Next question waiting for you. Take your time for this one, but give me the right, quickest answer. Question number 5 says 2.5 liters of a sample of a gas at 27 degrees Celsius and 1 bar pressure is compressed to a volume of 500 milliliters, keeping the temperature constant. The percentage increase in pressure you have to find. So guys, you have to find the increase in the pressure, not the pressure, right? The percentage increase. 100%, 400%, 500% or 80%. Easy one, right? Shikha, that was quick. Wow. Very nice. Really appreciate that. You changed your answer. You were saying A and then you're saying D, Shikha. Astha, A. All right. Subodh is saying B. Sachin Punia is saying D. Arjav is saying A. None of your friends in the audience will be helpful because A, B, C, D all are coming as their answers. Subodh is helping you guys, is saying P1 V1 is equal to P2 V2 is what we have to apply. Absolutely. That's, I am sure everybody of you have applied. So if you have, you know that we could easily get the pressure. P1 V1 is equal to P2 V2. Make sure that volume that you're keeping is 0.5 liters and not 500 ml, right? So the right answer would indeed come out to be option B, okay? So great job. Who gave the quickest answer here? Wow, great. Buck up now, Sanatan. Great job. You can see that. See, the scoreboard changes like this when you're quickest. So hashtag speed matters. Hashtag speed with accuracy matters. Let me quickly show you the answer right here. The calculations were very superbly simple. P1 V1 is equal to P2 V2 will give us pressure coming out to be 5 bar. And then it was about the increase in pressure. So what did you have to do? 5 minus 1 divided by 1 because initial pressure was 1 into 100, which comes out to be 400%. Great, superb. So audience was misleading. So moral of the story, guys, these do not listen to the audience here. Many of you are giving A and D, guys. Come on, buck up. Help your friends out here with the right answers, not mislead them. Cool. Cool. So question number 6, guys, coming in front of you. Let's see. For 1 mole of an ideal monoatomic gas, the kinetic energy is given as E. The URMS of the gas is, option A, everything is in root, okay? Even the 2E and the M. So 2E divided by M, whole root. B, 3E by M, whole root. Option C, 2E by 3M, whole root. D, 3E by 2M, whole in the root. Astha Gulati, sure, noted. We've noted it down. I have an announcement to make in the very end, so stay till the very end, okay? I'll let you know what we are planning for the future. Done? Raghav has given the answer. Let's see whether he's right or wrong. Cool, let's see. Shreya, Sanatan, take your time, but give me the right answer, okay? So Mystic Dragon is saying A here. Aditya Singh is saying C here. Charlie is saying C here. Aditya A. Zahir C. Aditya A. Ali is saying C. And Sachin Punia is saying D. Cool. Let's see. You can see that this is of no help. Nobody is giving unanimous unity wala answer. I think both C and A. Ali, see? This is what your friends are helping you out. Well, Sanatan, you're left. Let's have an answer from you and then we'll see what will be the right answer here. Average kinetic energy. Let me help you here. Average kinetic energy. What is it? If you know the average kinetic energy, RMS is equal to, there is a formula. So something will be coming from that average kinetic energy. The value of 3RT will be coming from average kinetic energy. Sanatan, quick, huh? Quick, quick, quick. Shreya, you changed your answer. What do we do? Sanatan, what about you? We got an answer from you? Very smart, very smart. Cool. Sanatan, we'll hear it out from you. What is the average kinetic energy? The formula. Unmute yourself. Okay, URMS.
Yeah.
What's the formula for root mean square speed?
The sum of squares of velocities of individual molecules are divided by the number of molecules root.
I am not interested in math. I know your favorite subject is math, but we do not require a root mean square formula of mathematics. We're talking about root mean square speed for the monoatomic gas. What's the formula that you have to apply? Okay, there are three types of speeds, if you remember: average, right, most probable, and RMS. And there's a formula with the root thing, remember? Remember? So the right answer here, what Shreya changed her answer to. So Shreya, I am sure that that was something that led Sanatan to probably mark A. Is it, Sanatan? Did your friend Shreya help you out, or
No, ma'am.
how did you come across A? Cool.
Some hints.
I'll assume it to be help coming out from Shreya. So we'll do one thing. We'll not give Shreya -1 for this. We'll give her a 0 because she's absolutely right. A is supposed to be the right answer. So though you changed your answer, take your time and give the answer. So we'll not have a -1 for you here, but I hope this has been noted down with the teammate ensuring the scoreboard. And Raghav gets a -1. Speed with accuracy, Raghav, right? And Sanatan here, he comes at 7. Brilliant. Okay, so ensure, guys, maintain the speed with accuracy and let the fun begin. That's what game is all about. Sometimes on this chessboard, somebody is going to play such a thing that, you know, you might feel, "Arey yaar, ye to hum bhi kar sakte the," but this is what game is all about, right? So brace yourself up and be ready for the next question. Question number 7. If saturated vapors are compressed slowly at constant temperature to half the initial volume, the vapor pressure will be, option A, becomes double, option B, becomes 4 times, option C, becomes half, or is it option D, remains unchanged? So Yokesh is asking, ma'am, how can we participate too? Yokesh, I mentioned, we roll out the participation form, the registration form every Friday. And we get this rapid fire Monday, obviously at 5 p.m. every week, right? So this is second in the series of rapid fire Monday for chemistry. And we're getting answers here. Wow, lovely, lovely. I would request the audience also, so that everybody is on the same track, write the question number and then the option, because sometimes, it's streaming late for somebody and you might be giving an answer which is reaching us at a wrong time. So I would advise all of you guys to give the question number and then the answer. Cool? So absolutely, Subodh Kapoor has helped you guys out here, and many of your friends have helped you out here. This saying remains unchanged, which is what all of you are also telling. Bang on correct. You know that vapor pressure is not supposed to change with the volume. A 1 liter volume of water, let's say, would not have a different vapor pressure as compared to a half liter volume, right? Then there'll be a mess. So D is indeed the right answer. Wonderful, yaar. Wonderful. I am so astonished to see the scoreboard. So Raghav, buck yourself up. Okay, for the next one, hashtag speed with accuracy. Let's see the answer here very quickly. So vapor pressure is independent of the volume of the gas. It depends only on the temperature. Therefore, vapor pressure will remain unchanged under given conditions. Okay, this is getting very excited. Very nice. Let's have the next question right in front of us. Question number 8. Dalton's law of partial pressures will not apply to which of the following mixtures of gases? Very easy question, very quick. Option A, H2 and SO2. Option B, H2 and Cl2. Option C, H2 and CO2. Option D, Cl2 and CO2. Very easy question. Buck yourself up. Very simple. Dalton's law of partial pressure. Not applied to. Swastika, you're joining late today, huh? Catching you. Now that we know you, we can catch you that you're coming late. Zahir is saying B. Aditya is saying B. Subodh is saying, we have C also. Ali is saying C. All right. Let's see. Arjav Gohil is also saying B. Sarthak is saying B. Cool. So H2 and Cl2 will combine, will react together to form HCl. You know that that's not what is supposed to happen. We cannot have reactive mixture. The mixture in the Dalton's law is supposed to be unreactive. So Shreya is nodding, and she's nodding because she knows she is right. And so is everybody else. Though Shreya gave, I believe, the quickest answer. So B indeed is bang on the right answer. Cool. So let's quickly read what the answer is very quickly. Everybody in the chat also was telling the same answer here. So this was pretty easy, I believe. Shreya is on 15. Sanatan is on 13. Raghav is on 11. Still, I believe, Raghav, you can, astonish everybody. Shreya, I'm sure you'll maintain this, scoreboard. And Sanatan, 13, an astounding 13. So I'm believing that anything can happen. So Dalton's law is applicable only to a mixture of non-reacting gases, like I have said, as hydrogen and chlorine gas may react and give HCl. That's why Dalton's law is not applicable. Cool? Simple, easy peasy, lemon squeezy. Are you ready for the next one? All right, the next one coming right on your screen. Let's see. Question number 9. The critical temperature of water is higher than that of oxygen because the water molecule has V shape, dipole moment, 2 covalent bonds, fewer electrons than oxygen. What do you think? Very simple, guys. Hashtag speed with accuracy. Parth, well said, huh? Very nice. So Swastika is saying, ma'am, can I participate in the next quiz? And she has already participated in one of the mathematics quiz. So Parth is saying, Swastika, let others also get a chance. Well said. I'll be mute here. Cool. All right. We have answers right in front of us. I think Subodh, Aditya, Nemish, every friend of yours in the chat is also bombarding B as the right answer. So have you guys. Of course, what other than dipole moment? What other than the polarity? What other, when we're talking about critical temperature, of course, we know intermolecular forces of attraction matters. And when intermolecular forces of attraction matters, something that quickly bombards the mind, floods the mind, is mu, that is dipole moment. So B is indeed the right answer. Well done, guys. Well done. So can we quickly have the scoreboard? Raghav on 14, Sanatan on 15, and Shreya, the lady out here, is leading it. Let's see whether this is what sustains or something changes. Raghav, Sanatan, let's see whether the lady here will lead or whether you find a way to come in the lead. Let's see with the next question. Question number 10. A bottle of dry ammonia and bottle of dry hydrochloric acid connected through a long tube are opened simultaneously at both the ends. The white ammonium chloride ring first formed will be at the center of the tube, near the HCl bottle, near the ammonia bottle, or you cannot predict. Good, Subodh. It will be an honor to meet you guys. It's so lovely when we meet you guys. Trust me on that. Nothing better. Okay, so Aditya here is saying B. Your friend Arjab is saying C. Subodh is saying near HCl. Avik is saying C. And out here, Raghav, Shreya, and Sanatan, all three of you are also saying near HCl. What law are you applying?
More the mass, less will be the speed, and HCl has Cl, which is obviously more mass.
So, which law? Law का नाम क्या है? अरे यार, ये तो बहुत famous law है.
It was like something Graham's.
Very good, right?
Done.
Absolutely. Graham's law, this is what we are applying, which what you have said. जितना ज़्यादा molecular mass होगा, जितना ज़्यादा species heavy होगी, उतना उसको चलने में मुश्किल होगी, right? So, of course, out of ammonia and hydrochloric acid, HCl is heavier. So, it would not be able to travel as much as ammonia would have traveled. So, ammonia would have already traveled and would be at the side of where HCl would be. And hence, you guys are absolutely right. It will be formed, the ammonium chloride ring will be formed first near the HCl bottle. So, B becomes the right answer. Very good. So Graham's law of diffusion, that's what we are applying. Let's quickly see the answer. Like I have said, according to the Graham's law, which is very important, you can't forget the law, guys. This is the most important topic from this chapter. Expect a question from your, for not just JEE Mains, JEE Advanced, or for NEET. Any competitive examination you give, this is one favorite question of examiner, Graham's law. What does it say? It says that the diffusion of a gas is inversely proportional to. So inversely, the denominator mein aayega, hai na? Inversely proportional to the square root of the molar mass of the gas. Since HCl is heavier, of course, its rate of diffusion will be less than that of ammonia. Thus, ammonium chloride vapors will be formed near the HCl bottle. Easy peasy. Scoreboard looks like what? Wow, Shreya is leading still. Raghav is on 17, Sanatan is on 19. Let's see what changes do we have in the scoreboard with the next question. Next question, question number 11, coming on your screen. Which of the following shows maximum viscosity? Ethanol, water, glycerol, ethylene glycol. Nemish, this law is in which chapter? Graham's law is certainly in the States of Matter, which is the topic of today's quiz, today's rapid fire quiz. So if you haven't completed the chapter, make sure you do and revise with the help of this quiz. So you can always come back to this quiz and revise. These are very important topics that we have picked up from the whole chapter, right? Chapter is huge, but we ensure that we pick up the most important from the examination perspective. Cool. Let's see. All right. So looks like, Shreya, let's hear it from you. What's the formula of ethylene glycol? How many OH alcohols are there?
One OH.
That's ethanol. Ethylene glycol. How many OH? Ethanol is C2H5OH, right? So CH2OH, CH2OH. That's ethylene glycol. But how about glycerol? Raghav, Sanatan, how many hydroxides in glycerol that you have answered? Hmm?
2.
And how about ethylene glycol then? Why such partiality with ethylene glycol if glycerol also has 2? I just told you ethylene glycol has 2. So that means you guys do not know the formula of this very important compound that you will be looking very, very carefully in the alcohols, phenols chapter. Shreya or Sanatan, which class you are in? I didn't hear your class. Did you tell? Which class you're in? Raghav is 11th.
I'm class 11th.
Okay, Shreya?
Class 12.
Class 12. So if you've done alcohol, phenols, and ether, you would know glycerol has 3 alcohols, like 3 OH, 3 hydroxy group. It's a triol, it's a trihydroxy group. So that's why it has maximum hydrogen bonding. Glycerol is 3, ethylene glycol, guys, is 2, ethanol is 1 OH, right? So make sure you remember viscosity is highest. That's why for glycerol. So C becomes the right answer. Yokesh is saying 3 for glycerol. So 3 are the number of hydrogen bondings. Now I'm sure after this quiz, you will never forget the formula of glycerol. So imagine 3 carbons in straight chain with OH, OH, OH. How about ethylene glycol? 2 carbons, OH, OH. How about ethanol? CH2, CH3, CH2, OH, right? That's how it is. So let's quickly see the answer right here. The answer is C. Hydrogen bonding and strong intermolecular interaction increases their viscosity, like, you know, more the number of OH groups, more will be the hydrogen bonds, and greater, of course, will be the viscosity. Jitna zyada intermolecular forces of attraction will be hydrogen bonding, utna zyada viscosity. So water can show hydrogen bonding due to both hydrogen and OH. Ethanol has only 1 OH. Ethylene glycol has 2 OH, whereas glycerol, like I said, CH2OH, CHOH, CH2OH, 3 OH. So that's why answer will be C. Cool. So Raghav, Sanatan, wow, oh my God, that's crazy. Scoreboard has drastically changed, but nonetheless, like, you know how things are shifting, right? So with next question, hashtag speed with accuracy, okay? Next one right in front of us. Temperature at which RMS speed of oxygen is equal to that of the neon at 300 Kelvin is 280 Kelvin, 480 Kelvin, 680 Kelvin, or 180 Kelvin. Par Chavan, you're saying, ma'am, can we say there is only 1 OH in water? Yes, there is 1 OH and 1 H. Do not underestimate the power of common man. H here. H is the most underestimated element of the whole periodic table. So do not underestimate. Right? Though what you're saying is absolutely right. We can certainly say there's 1 OH. You know, guys, when we give paper, any kind of paper, any competitive examination, be it JEE Mains, Advanced or NEET, you would see that you know it all. You know the answers, you know the concepts. Once you revisit the answers, you would feel that, "Arey yaar, ye to mujhe aata tha." But then also you would feel that, "Yaar, ye to main galat karaya, but ye to maine kara hua tha, how could I?" You know, you would start becoming, going in that zone. How could I? Just because It's all about pressure. So if you understand pressure handling now, things will be absolutely seamless for you guys. So I can see pressure developing up, which is what you must embrace very happily, wholeheartedly, because pressure will make you stronger, okay? Just like in the case of diamond, pressure makes the carbon allotrope. Diamond is the one of the very hardest substance. How come? Pressure. It is able to endure the pressure. So my diamonds out here, Raghav, Shreya, and Sanatan, all three of you have given B as the answer. And Sanatan was quickest this time, yeah? Wow. So indeed, I think you guys are awesome. B is indeed the right answer. You can easily remember the formulas, guys. I usually teach the trick like this. राम वनवास गए थे, कितने लोगों के साथ वनवास गए थे, कितने टोटल लोग थे? 3. So Ram, remember 3. ऊपर न्यूमरेटर में आएगा 3. 3 RT by M. This is common. RT by M for beat, most probable speed or average speed or RMS speed. RT by M is common. अगर आ जाए most probable, MP, MP2. Remember it like this, MP, MP2. So RT by M is common, the root is common, 2 RT by M. That becomes the formula. तीसरा क्या है? Average. A से याद रखेगा 8 pi. 8 pi. That 8 is coming first and then pi is coming first. So 8 RT by pi M. Remember it like that. Okay, so remember the 3 formulas, very important from examination perspective. So right answer here, the formula that you have to apply. Ram 3 लोगों के साथ वनवास गए थे. So root 3 RT by M. Once you put the values RT, T here, you have to apply, you have to put, right? You have to find out T. आपको पता है oxygen पूछा है, neon पूछा है. Can we quickly see the answer? We can see that this is how we put the values. Root 3 RT by M, U1 is equal to U2. The RMS velocities are given to be same. So T1 by M1 is equal to T2 by M2, all in the root. And then you can square both the sides. So you can simply find out the answer. It becomes 300 into 32 divided by 20. That comes out to be 480. And rock and rolling. Sanatan gave the quickest answer here. Let's see how the scoreboard is looking like. Wonderful, wonderful. Raghav, Shreya are together having 23 as their scores. Wonderful. We have a tie coming up. And Sanatan, bang on, 26. Anything can happen. Okay, let's see. Next question. Question number 13. Very quick, very easy. The gas which can most easily be liquefied is oxygen, nitrogen, ammonia, carbon dioxide. Hashtag speed with accuracy, guys. Come on. Dissipate the pressure and give the quickest right answers. Typing skills, mindfulness, and confidence is all it takes. Audience में कितना chill है ना? कितने मस्त होकर सभी इतनी जल्दी आंसर दे रहे हैं. See, because there's nothing to lose, हाँ? ऐसा ही पर्सपेक्टिव एग्जामिनेशन में आ जाए. When you are detached कि यार मैं कर रहा हूँ वो सही है या गलत है, जो मैं कर रहा हूँ वो मेरे को नेगेटिव तो नहीं दे देगा. When you have so many thoughts going on in your head, when there is triggering of thoughts all the time, that's when you create a mess. But when it is all clear out there, like for our audience who are bombarding C like crazily, even before Shreya did, I think that's what we require. Ease, confidence in yourself that I know it, and keep reinforcing that. C is indeed right answer. So ammonia, you know why it can be liquefied easily. Let's see the answer. Because of the intermolecular forces of attraction, you know that it is capable of possessing hydrogen bonding. So can we have the answer right on the screen? Greater the forces of intermolecular attraction, easier will be the liquefaction. Since among the options, ammonia had permanent dipole moment, the intermolecular forces of attraction will be highest in ammonia. Hence, you can see that it is easily liquefiable, right? So ammonia is indeed right. What's the scoreboard? Brilliant. Sanatan is leading it, 28. Shreya, 1 less, 27. Raghav, 1 less, 26. That's crazy. So the thumb rule is, guys, hashtag speed with accuracy. Raghav, agar +4 diya to automatically you would see that you will come ahead, right? So speed with accuracy, dissipate the pressure of your head. Okay, be very quick in the next one. Last two questions to go. If you have a tie, then we will be having tiebreaker questions also, right? So next question on your screen now. 2 mole of ammonia and 1 mole of HCl are kept in 8.21 liter container. The temperature is 300 Kelvin. Calculate the final pressure after the reaction. Option A, 0.5 atm. Option B, 1 atm. Option C, 3 atm. Or is it option D, 4 atm? Nirmal, how many questions are there in rapid fire? There should be 15 questions, but if there will be a tie, we'll have a tiebreaker question. Till the time the tie is not broken, we'll keep having the questions. We'll make sure out of the 3 participants, only one comes out as a winner. All right, let's see. Question number 14. Okay, so this is very interesting. What is the, you can see we have 2 mole of ammonia, 1 mole of HCl. What are they going to combine and give? You already saw one of the questions, which was about ammonia and HCl. We get ammonium chloride, which is a solid. We do not include solid when we are talking about pressure because it's all about pressure of gases. And here we're going to utilize the most important equation, PV is equal to nRT. What is P? We need to find out. What is V? 8.21 liters given in the question is equal to N. R is, everybody knows, 0.0821 you can keep because we are talking about ATM, so ATM liter per Kelvin per mole, that works for us. क्या रह गया? PV is equal to nRT, temperature be 300 Kelvin. The game is all about finding N, the moles. So moles कितने ले रहे हो आप लोग? क्या moles दिए? 2 moles? 1 mole?
1.
So that's indeed right. 1 mole has reacted with HCl. That's why the moles of ammonia which is left is 1. And that was the key. So once you keep that in mind, I believe what you will get is, can we have the answer first and then we'll come to the correct answer? We can see that when we quickly solve, 3 comes out to be an answer. You can see that 10 to the power minus 2 will come because 8.21 and 0.0821. You can just solve it. You get 10 to the power minus 2. 300 into 10 to the power minus 2 will be 3. So total pressure will come out to be 3. So right answer will come out to be C, not B. So C becomes the right answer, guys. PV is equal to nRT, the most easy, most important, and the thumb rule equation, ideal gas equation, isko koi nahi bhul sakta hai. This is what we have to apply, and what we get is 3 as our answer. -1 for all 3. Wonderful. Yippee, loving it. Cool, let's have the scoreboard. So it's like very similar. Raghav 25, 26, 27. What better? Like, I've never seen such a nice scoreboard. And next can be like a crazy game. Question number 15 on your screens now. A and B are 2 identical vessels. A contains 45 gram ethane at 1 atm and 298 Kelvin. B contains 75 gram of gas X2 at same temperature and pressure. Vapor density, guys, very carefully. Vapor density. Right? Quickly, let's see the answers coming from you guys also. Last question, Sumit, don't worry. But if there'll be a tie, we'll have more questions coming up. All right, that's very interesting. Why is it interesting is because everything is alike, ठीक है? Identical vessels हैं, बोले तो volume constant है, volume same है, volume similar है, temperature similar है, लिखा ही हुआ है at same temperature, same pressure. हमें पता है pressure same, temperature same, volume same, and we are supposed to find out, you know, the vapor density of X2. There has to be something that should be the base. PV is equal to nRT, PV, RT, everything is same. That means N1 is equal to N2. That means weight 1 by molecular mass 1 is equal to weight 2 by molecular mass 2. Ethane, we have 45. Ethane, C2H6, 24 plus 6, 30. So can we quickly have first the answer right in front of us? You can see that we're just equating the moles. Na is equal to Nb. Weight of ethane by molar mass of ethane is equal to weight of X2 divided by molar mass of X2. Weight of X2 is given to us. So 75 into 30 by 45, 50. And vapor density, how I make my students remember this is twice. Video games sabko pasand hai? How, haath khada karna zara. How many of you like the video games? Yes, Sanatan was the first one to raise the hand. Shreya is like, I don't like it. Don't like it. High five, Shreya. Though I can make you remember it like this. Twice into vapor density is equal to Mahamaza. Mahamaza, matlab maze bhi double. Mahamaza is equal to twice into vapor density. So vapor density हमें find करनी थी, तो क्या हो गया? 2 into VD is mm. So mm by 2 will be vapor density. That comes out to be 25. So none of you is correct. Can we quickly see the right answer once again on the screen with the question? 25, that means question is 15. Answer is option A. And -1 for all three of you once again. Let's see the scoreboard. Wow, like this came out to be seamless. And this is what that can happen, guys. Anything can happen. You can see Sanatan 26, who maintained, I think, a negative score for first three. And look at him. Sanatan, many of your friends were already vouching. कोई setting तो नहीं है ना यहाँ पे? Huh? Everybody was vouching for you, Ki Sanatan. Probably you had your friends in the chat, huh? That seems so.
Actually, I am revised my previous year question and JEE question and books problems. Although I can maintain my capacity, I am not read much question, but I am already read this chapter, but
it is clearly evident, Sanatan, you have actually braced yourself in the last segment of the session, right? Today's episode is something of great relevance for us to understand something. What? Shreya was performing so well, and she's indeed the winner for today from my heart, in fact, because you were tremendous throughout. But pressure is what is, you know, usually I see females getting a negative hand on, you know, they get pressurized very simply, very easily. We do not have to, guys, right? This is for everyone out here in the chat, and it's for Shreya, for you. Female power, make sure this time the first JEE topper, NEE topper has to be a girl. This is something coming out from my heart. But keeping that aside, Sanatan, pressure is something that we have realized here. When you overcome that and there is a race that comes out from our heart, we indeed can win. Raghav, you maintain a thorough, beautiful smile throughout the session. So thank you for that. You were really sportive and you were playing awesome. It's just that hashtag speed with accuracy. A few little -1 here and there, and you could see how the scoreboard changed. And this is exactly what will happen in the competitive examination also, guys. Few negative markings, no matter how brilliantly you have performed, maybe more brilliant than somebody who is scoring more than you, but that is the negative marking that has placed you below. So be very careful. Hashtag speed with accuracy. Accuracy is very important. Negative marking is something which is deadly at places. That's why mock tests, platforms like this, where we, you know, find fun in the learning. So be innovative, be creative. Sanatan, round of applause for you. You are a clear-cut winner today. Runners-up is Shreya, Raghav is 24, and you guys were so brilliantly close that from my heart, all three of you are clear-cut winners. Amazing job, guys. I thoroughly enjoyed the session. I hope everybody in the audience also has enjoyed the session thoroughly, right? Few quick updates, guys. We are coming up with few of the things. Let me tell you, I have few announcements to be made. We are coming up with new Mission JEE 2022 series. What is it all about? Every 7 p.m. we'll be coming up with the most important topics every day at 7 p.m. I know some of you have been writing to us about the timings, and we'll certainly see what can be done. But for now, 7 p.m. is what we have decided as per everybody's timing. We'll be live and we'll give you concepts in the most innovative fashion, in the most creative fashion, in the loving fashion, in the remarkably awesome fashion. And you will see that you will thoroughly enjoy these sessions for sure, right? We have a session which is lined up tomorrow. To know more, do subscribe to the channel. If you liked the session, hit the like button. Do subscribe to the channel to get the more notifications. It was lovely meeting 3 beautiful, awesome students today. I hope to meet all of you one by one, through the 3 participants. Eventually I would love to meet as many students as possible. It's a boost for us as well. It was amazing meeting 3 participants out here and amazing audience out there in the chat. Keep it going, guys. I wish you all the great luck. Be in best of your spirits. Take a very good care of yourself and make sure you fall in love with learning. Bye-bye.